I'm Katie with your GTV Tech Tip. When checking for wire standards or the type of wire to use, letters AWG may appear on the side of the wire's insulation after a number. AWG is short for American Wire Gauge and is the standard wire gauge system in North America. It has also been referred to as the Brown and Sharpe wire gauge. The size of the wire gauge's diameter will decrease as the gauge increases. This would mean a 16 gauge wire is smaller than a 14 gauge wire. There are 40 different gauge sizes, and for each successive gauge, the difference is multiplied by 1.12293. The sixth power of this value is close to 2, so the difference of 6 gauges is roughly twice the diameter size. To find out more about wiring, make sure you check out our other videos on GTV. Welcome to GTV. Today I will be showing you some basic principles of wire and cables. This particular topic can be discussed in great length, so I will only focus on certain characteristics of wires and cables in this video. Wires and cables are designed to carry electrical current from one point to another. The conductors can either be stranded or solid. The stranded wires offer more flexibility and are less rigid than the solid counterpart of the same size. The more rigid, solid core conductors tend to be less expensive and are often used in residential wiring. Stranded wire conductors can be made up of many conductors twisted together in different configurations. Some cables may serve as a conduit with other wires inside that in turn are comprised of groups of stranded wires. Cables also may have a shield or armor surrounding the wires. This is an electrically conductive material designed to prevent EMP, electromagnetic interference, or radio frequency interference, as well as to provide an extra level of protection to the wires. Shields can be braided, spiral, or wrapped in a foil. The insulation and the outer jacket of the cable and wires is also an important factor. The types of materials used are usually a thermoplastic or thermoset. A thermoplastic material can soften under heat, while the thermoset material could vulcanize when exposed to heat and pressure. The insulation material may also offer a difference of protection. Sizes of wires and cables can vary between region, with the three most popular being the AWG, Imperial, or Metric. In the United States, the AWG, known as the American Wire Gauge System, is the standard. The AWG increases in size as the gauge size gets smaller. For every 6 gauges in difference, the lower gauge wire is about twice the size and diameter of the higher gauge wire. For example, a 10 gauge wire is twice the diameter of a 16 gauge wire. Wires and cables, along with thousands of other products and services, are available at Galco.com.
In a wire or cable, the conductor is responsible for doing the main job, moving electricity, energy, or signals from one point to another. The conductor is located at the center of the cable, and it's what all the other layers of the cable work around to protect. Metals are generally conductive, but some metals are better suited for this task than others. Silver, copper, aluminum, nickel, and tin are some of the most common metals used in conductors, and each has its own advantages and disadvantages. Aluminum is one popular conductor. It's lightweight and affordable and can be used in a wide range of projects. However, aluminum is less conductive than copper, another popular option. Copper is a good conductor and moves electricity quickly. It's both inexpensive and versatile. In addition to being used bare, copper can also be dipped. Coating the copper with another metal can enhance specific qualities necessary for different applications. For example, in tinned copper, the layer of tin protects the copper from corrosion at high temperatures and makes the wire last longer. Another benefit of tinned copper is that it's easier to solder than bare copper, without a huge increase in cost. Silver is the most conductive material, but its high price limits its use to very select applications. Silver-plated wire is a much more common option. It's less expensive than using silver alone, and it still provides many of the excellent conductive qualities of silver. It not only improves the wire's conductivity, but it also allows the wire to operate over a wide temperature range, from -65 degrees Celsius to 200 degrees Celsius. Silver-plated wire is commonly used in aerospace applications. Nickel-plated wire also operates in extreme conditions and over a wide temperature range. If the nickel plating is thick, it can withstand temperatures up to 750 degrees Celsius. Nickel also adds a layer of excellent corrosion resistance. High-strength alloys are other materials commonly used as conductors. These are typically silver-plated or nickel-plated as well. As you can see, conductors are available in a variety of materials, but it isn't just what they're made of that makes them different. It's also how they're configured. Conductors can be either solid or stranded. Solid conductors are made of one piece of metal, while stranded conductors are made of several threads of metal. Solid conductors are inexpensive and mechanically tough, but not very flexible. Higher strand counts means more flexible conductors. Stranded conductors are generally a little more expensive than their solid counterparts, but the flexibility they provide can make a big difference in many applications. For stranded conductors, there are several variations on how those strands can be laid. While bunched is most common, some specialty cables have other options, such as concentric, unilay, and rope lay. Bunched strands are simply gathered together without any specific arrangement. They're the least expensive option because they involve the least labor. Concentric, unilay, and rope lay all have the strands arranged in a circular pattern. But in concentric stranding, the layers alternate in terms of their twist direction. In unilay stranding, every layer is twisted in the same direction. Rope lay is the most flexible option. We've learned that there are several options regarding the conductor to consider when specifying electrical wire. Each material and configuration has its own advantages and disadvantages. Make sure to evaluate the requirements of your specific application when choosing the appropriate conductor for your project needs. Allied Wire and Cable is a family-owned and operated distributor and manufacturer of electrical wire, electronic cable, heat shrink tubing, and wire management products. Here at Allied, we've given our customers the best in customer service, product selection, and quality since 1988. And we've grown into one of the largest distributors of wire and cable in the country. Throughout our history, we've continued to hold on to our family values and are proud of the growth we've enjoyed while remaining a family-run business. Allied Wire and Cable carries a wide variety of high-quality products for numerous industries, including automotive, military, OEMs, and more. We are ISO 9001-2008 certified, so you can rest assured that the products you receive will be of the highest quality available. To help customize your products, we offer a variety of value-added services, including striping, twisting, braiding, cut and strip, custom packaging, and special labeling, to name just a few. When you need something extraordinary, our experienced sales representatives and engineers can help you design a custom cable from start to finish that fits your application perfectly. We guarantee that all orders on stock materials that are received by 1 p.m. Eastern Standard Time We'll ship out the same day. And with our low minimum of just $50, you can get the amount you want in the time frame you need. Allied has office and warehouse locations around the United States, which allow us to ship your orders from the most convenient location. A specific sales representative is assigned to handle your account personally. That means one point of contact and the trust and assurance that comes with having a personal relationship with our customers. For more information about the products you've seen in this demo or any other Allied products, contact Allied Wire and Cable today. Call 1-888-325-1788 or visit our website at www.awcwire.com.
We're so used to them that we barely notice that electrical wires are all around us. There are aerial and underground cables running along our streets and to our homes. They're behind our walls and inside our electrical appliances. To make color-coded electrical wires, they use what's called rod, made of either solid copper or solid aluminum. They feed the rod into a machine that draws it out through a series of lubricated pulleys and dies, stretching, lengthening, and thinning it out. And eventually winding it onto a large bobbin. What was once a rod 4/10 of an inch in diameter is now just 8/100 of an inch, the width of about a dozen human hairs. They load the bobbin onto what's called a stranding machine. They cold weld the end of one bobbin to another, guaranteeing an uninterrupted flow once they start up the machine. At high speed, the stranding machine twists 7 wires together, forming an electrical conductor, also called a bare conductor. This is a low-voltage conductor, under 1,000 volts, the kind you find in the cables that run electricity to your home. Bare conductors need to be insulated, so the people handling them won't get an electric shock. A plastic extrusion machine coats the conductor with polyethylene or PVC. This insulates the conductor. This is what the polyethylene looks like in its raw form. As the conductor exits the machine with its new insulation, a precision laser gauges the diameter to make sure the insulation is uniform and the right dimension. The extrusion process has heated up the conductor, so it has to be cooled down with water. Sometimes 2 or more conductors are twisted together. When that's the case, a printing machine applies a white stripe to identify which is which. The client who's ordered the conductor specifies the colors of insulation. It chooses them based on how it wants to color code its electrical wiring. Several conductors are often grouped together to form a cable. The plant performs a voltage test, immersing the cables in water to make sure they don't short circuit. These medium voltage cables can carry from 1 to 46,000 volts of electricity. They're the type used for underground power lines. They're insulated the same way low-voltage cables are. The plant prints the date of manufacture, the voltage, and any other information the client has requested. The cable goes onto a reel to be tested before it's shipped out to its destination. In the middle of the cable, surrounded by copper grounding wires and a host of other components, is the heart of the electric cable, the bare conductor.
Much of today's high-tech equipment requires specialty wires and cables. From stage lighting to medical devices to robotics, wires and cables have to be custom designed and expertly manufactured to perform in a specific way and withstand various environmental conditions. Cables can be designed to withstand high temperatures or perform special functions, such as sensing pH levels or proximity to objects. At the heart of a cable are electrical wires, called conductors. A conductor begins as a bare copper wire. This extrusion machine coats it in plastic. Chilled water solidifies the plastic around the wire as insulation. This isolates each wire from its neighbors. Every conductor passes through a machine called a spark tester. It runs current through the conductor to ensure the insulation is flawless. If there's even the smallest break in the insulation, the machine will sound the alarm and locate the spot. The conductor then enters a machine called a cabler. It unrolls spools of insulated conductors and unites them with other components to form the cable's inner workings. At the center of this particular cable is a twisted pair of insulated conductors. Around them go color-coded insulated conductors and fillers to fill in the gaps between the conductors, giving the cable a smooth cylindrical shape. Here, the fillers are strands of polypropylene foam. An orientation plate aligns the components in the proper configuration as they enter the cable assembly die. The components exit the die with the fillers wound around the insulated conductors, which wrap around the central wire. The next machine, called a taping head, wraps binder tape around the cable. This tape holds everything tightly in position so that the assembled components don't unravel. This is a different type of cable assembly machine. Like before, all the insulated conductors unroll from their reels and travel through the holes of an orientation plate. Dies divide the 6 conductors of this cable into 3 groups of 2, twisting the conductors of each pair together. The machine then wraps each twisted pair in a shield made of aluminum-coated polyester. Shielding eliminates what's known as crosstalk, signals interfering with each other. The next die joins additional wires that don't need to be shielded to the shielded ones. Then everything gets twisted into one cable. Then a final twisting, seen here in slow motion. The actual speed is 1,000 revolutions per minute. The next machine wraps tissue paper around the cable. Then an extruder applies a jacket made of a plastic and rubber compound. The tissue paper acts as a separator, preventing the jacket from sticking to the cable inside. Sometimes, instead of tissue paper, the cable runs through a bath of talc. Talc is a mineral that absorbs heat, so, just like tissue paper, it prevents the jacket from sticking. Once again, as the cable exits the extruder, chilled water solidifies the molten material into a jacket. A wheel with raised lettering imprints the manufacturer's name and technical specifications into the jacket. Certain jacketed cables need a braided shield to eliminate electrical interference. This machine has 48 carrier spools, each of which holds 10 wires made of tin-plated copper. As the jacketed cable moves upward through the machine, the spools move in a programmed pattern, weaving the shield around the cable. From there, a last trip through the extruder for a final thermoplastic jacket. And the custom-made cable is ready to be connected and powered up.